They didn't give him medals. They didn't paint his name on the side of a fighter. And unless you're a hardcore aviation nerd, you probably don't know who he was. But in the winter of 1939, a quiet British engineer named Dr. Henry Charles Watts and his team at Rotol Airscrews Ltd made a change so dramatic, so mathematically perfect, that it transformed how the Supermarine Spitfire fought in the sky. A change that made early Spitfires climb nearly 25% faster, in some cases more, literally overnight. Not by improving the engine, not by changing the airframe, not by adding horsepower, guns, or weight, but by doing something almost absurdly simple. They swapped the propeller. Now, at first glance, that sounds almost boring, like replacing a part on your car. But to understand why this mattered, you need to picture the opening months of World War II, when the Royal Air Force still didn't know if its fighters could match the emerging Luftwaffe threat. Early Spitfires rolled off the line with two-pitch wooden propellers, essentially blades that could change between only two preset angles. It was a good system for 1938. Fine for cruising, fine for gentle climbs. But in real combat, in frantic scrambles, in high-G maneuvering when your life depends on raw acceleration, those old props were holding the Spitfire back. Pilots didn't realize it at first. They knew the Spitfire felt slippery, agile, and sharp, but it was underperforming exactly where it mattered most, the climb rate. The thing every fighter pilot needed to gain the advantage, to take the high ground, to bounce enemy bombers before they could hit their targets. When No. 19 Squadron at Duxford began flying early Spitfire Memca 1s in 1938, their pilots complained that takeoff felt sluggish. Getting altitude was a chore. Intercepts had to be perfectly timed, otherwise the squadron would still be climbing when the bombers were already past the coast. The Air Ministry blamed training. Pilots blamed fuel mixtures. Supermarine blamed propeller makers. And in a quiet test bay in Gloucester, Dr. Watts nodded, rolled up his sleeves, and said, "Give me a week." Rotol, short for Rolls-Royce and Bristol, the two companies that formed the joint venture, was experimenting with something revolutionary, the constant speed propeller. This wasn't just a mechanism, it was a philosophy of flight. Instead of the propeller being fixed or limited to two angles, a constant speed prop automatically adjusted its blade pitch in real time to maintain the most efficient RPM for whatever the engine demanded. Think of it like gears on a bicycle. You wouldn't climb a hill in top gear. And early Spitfires were basically stuck in top gear. The Merlin engine needed the propeller to bite into the air for maximum thrust. The old props simply couldn't do that at low speeds. The blades were too coarse, too stiff, too inefficient. Watts explained it in beautifully British understatement. The aircraft is, in essence, being strangled by its own air screw. With a constant speed Rotol unit, the Spitfire would behave like an entirely different machine. On takeoff, the blades automatically fine-tuned themselves to a low pitch, grabbing the air like paddles. As speed increased, the blades coarsened smoothly, reducing drag and keeping the Merlin engine at peak power. It meant that the pilot no longer had to choose between climb performance and cruise performance. The propeller chose for him, hundreds of times a minute. And so in early 1940, No. 54 Squadron received the first operational batch of Rotol-equipped Spitfire Mach 1s. They expected a mild improvement, maybe a few percent, nothing dramatic. What they got instead was aviation sorcery. Squadron leader James Leithart climbed into his newly modified Spitfire in February 1940 and performed a side-by-side trial with an unmodified two-pitch Spit from the same unit. They took off together. Leithart pushed his throttle forward and felt something he had never felt in a Spitfire before. Power. Real, low-speed, muscular thrust that pinned him to his seat. His aircraft practically launched down the grass strip. Within 30 seconds, he was already pulling away. At 1 minute, he was climbing hundreds of feet higher than the other pilot. By the time both aircraft hit 10,000 feet, the constant speed-equipped Spitfire was 3/4 of a mile ahead. That wasn't just better, it was transformational. Engineers calculated the improvement as a 24 to 25% increase in climb rate, depending on altitude and conditions. In some high-power climb trials, the improvement was measured at more than 28%. This single upgrade took the Spitfire from excellent fighter to world-leading interceptor. The Air Ministry's reaction? shock, then denial, then frantic orders. By May 1940, with the Battle of France collapsing, they demanded that as many Spitfires as possible receive Rotol propellers immediately. The factories couldn't keep up. Rotol engineers began working double shifts. RAF maintenance crews were trained to replace propellers in days. Squadrons across Britain lined up for the conversion. The results were immediate and stunning. Pilots reported that takeoffs now required less runway. Dogfight acceleration from low speed improved dramatically. Most importantly, Spitfires could now intercept Luftwaffe raids far earlier in their attack runs. German bomber crews noticed too. They wrote in diaries about climbing British fighters that appear from nowhere. Luftwaffe escort pilots complained that the Spitfires were suddenly faster into the vertical, and the timing? Perfect, because the Battle of Britain was only weeks away. But the story behind this upgrade isn't just about machines. It's about the engineers who built them and the decisions that almost never happened. You see, the RAF originally intended to equip the Spitfire with de Havilland variable pitch props, not Rotol. But supply shortages and engineering delays meant that only a fraction of Spitfires got the upgrade before war broke out. If Rotol hadn't stepped in when they did, if Dr. Watts hadn't pushed constant speed development so aggressively, the RAF might have entered the Battle of Britain with fighters that were objectively inferior in climb rate and interception performance. One historian put it bluntly, the Rotol propeller gave the Spitfire time, and time wins air battles. Because every second mattered, every foot of altitude mattered, every scrap of performance mattered when facing experienced Luftwaffe pilots. And while test pilots and squadrons celebrated the new propeller, frontline pilots discovered something else. The Rotol propeller gave the Spitfire a new personality. It felt hungrier, more responsive, more alive. Geoffrey Wellham, one of the youngest Spitfire pilots in the Battle of Britain, described the difference like this. With the constant speed propeller, the aeroplane felt as though it wanted to go to war. And that is not an exaggeration. When the Luftwaffe struck British convoys in July 1940, Rotol-equipped Spitfires often reached combat altitudes 1 to 2 minutes faster than their two-pitch counterparts. That meant the Rotol fighters got the bounce. Attacking from above, choosing when and how to strike. Air combat is chess at 400 miles per hour. Altitude is your queen, and Rotol gave the Spitfire hers. And that brings us to the part almost nobody talks about, the unsung human drama behind the engineering. Because the Rotol propeller wasn't simply invented, delivered, and celebrated. It was resisted. It threatened existing contracts. It embarrassed decision-makers who had insisted the Spitfire's performance was already optimal. And it exposed a truth the Air Ministry hated to admit. The fighter that was supposed to be perfect still had a major bottleneck. Dr. Watts and the Rotol team fought quietly, behind the scenes, to push their propeller into service before it was too late. Test pilots argued heatedly with conservative bureaucrats who doubted the reliability of automatic pitch control. Some squadron leaders feared their ground crews wouldn't understand the new technology. Others argued that pilots would be confused by the new engine handling. There was even a brief attempt by one procurement officer to delay the rollout until more comprehensive administrative evaluations were completed. That nonsense ended the moment the first constant speed trials were compared against real combat reports from France, where British fighters were struggling to hold altitude against Messerschmitt Bf-109s. Suddenly, the debate vanished. The numbers were too clear, too stark, too urgent to ignore. And so, the Rotol propeller became one of the fastest widespread upgrades in RAF history. Crews swapped out two-pitch props for constant speed units on flight lines, in hangars, even outdoors in the rain. They worked by lamplight. They worked with freezing fingers in early spring winds. They worked as Luftwaffe reconnaissance aircraft flew overhead, photographing the very bases where the upgrades were happening. The pilots who tested the newly upgraded Spitfires walked back to their dispersal huts with wide, stunned smiles. They all said the same thing. It climbs like a different aeroplane. Some even said, it climbs like a bloody rocket. And that's not just poetic exaggeration. The official RAF graphs showed a climb from 0 to 20,000 feet in over a minute less than before. In combat terms, that is an eternity. That can be the difference between intercepting a bomber formation on the coast or meeting them already over London. It can be the difference between attacking from above with the sun at your back or clawing upward helplessly as enemy fighters dive toward you with guns blazing. When pilots of No. 602 and No. 609 squadrons scrambled to meet the first major raids of August 1940, they shot upward into the sky with a confidence they had never felt before. Some later recalled being momentarily startled by the speed of the climb, as though the aircraft were suddenly lighter, hungrier, more eager to get to altitude and fight. And the Luftwaffe noticed. German pilots wrote frustrated notes about Spitfires that appear suddenly from above and climb past us even as we dive. The Bf-109 still had excellent climb performance at higher speeds, but the Rotol-equipped Spitfire now had the edge at low and medium speeds, the speeds that mattered during quick scrambles and furious turning fights over British fields. But something else was happening too. The Rotol propeller didn't just affect climb, it improved takeoff safety. Before the upgrade, many early model Spitfires had long, shallow takeoff runs. On wet grass, some even struggled to become airborne in time. With Rotol props, the increased thrust at low airspeed meant Spitfires leapt forward with authority, especially important during emergency scrambles when every second counted. It also improved acceleration in dogfights. When a pilot slammed the throttle forward after a tight turn, the constant speed prop automatically fine-tuned the blade pitch to convert engine power into thrust efficiently. Pilots felt this as a stronger pull, allowing them to re-enter a climb or chase more quickly. Sometimes the difference between life and death in a dogfight is a single heartbeat of acceleration, and Rotol had just delivered it. And yet, for all these battlefield advantages, the engineers behind the upgrade remained almost invisible. While pilots like Douglas Bader, Sailor Mallon, and Brian Lane became household names, the men who delivered the hardware that made their victories possible stayed in the background. Dr. Henry Watts was one of them. He wasn't a fighter pilot. He didn't fly Spitfires in combat. He wasn't in the headlines. But he understood something essential, that in aviation, small mechanical details can produce enormous strategic effects. His constant speed mechanism wasn't glamorous, but it was brilliantly designed, meticulously tuned, and rugged enough to survive combat abuse. The process of refining the propeller was painstaking. Engineers had to find the perfect balance between responsiveness and stability. Too rapid a pitch change would cause engine surges. Too slow would waste precious thrust. The hydraulic governor inside the hub needed to operate flawlessly under extreme vibration, sudden RPM shifts, and rapid changes in throttle. It had to resist oil leaks, temperature changes, and the centrifugal forces trying to tear the blades off the hub at thousands of pounds of stress. Every time a Spitfire climbed hard at full boost, that little governor was fighting physical forces no human hand could manage. And it worked. Beautifully, predictably, invisibly. The perfect example of engineering that seems simple only when done perfectly. As the war progressed, the influence of the Rotol constant-speed propeller rippled across the entire RAF. The Hurricane received it. Later marks of the Spitfire received improved versions with metal blades. The concept of constant speed control became standard not just in Britain but across the world. American fighters like the P-51, P-47, and P-38 all benefited from their own constant speed systems. The idea swept across aviation so thoroughly that today it is taken for granted in any high-performance propeller aircraft. But back in 1940, it was a revolution, a quiet one, a technical one, but a revolution all the same. And here's the part that aviation historians love most. When you examine many of the surviving combat reports from the Battle of Britain, you start to see a pattern. Pilots describe turning inside German fighters because they regained energy quicker. They describe being able to pull up into the vertical more aggressively. They describe intercepts that would not have been possible just 3 months earlier. Again and again, the same subtle advantage appears. Altitude when needed, acceleration when demanded. These are the fingerprints of the Rotol propeller. One of the most telling moments came from a veteran German pilot interviewed decades after the war. When asked why the Luftwaffe failed to break the RAF, he said this: "They always reached us sooner than we expected. "We thought their fighters would take longer to climb, but they did not." That comment, simple as it is, encapsulates the impact of the upgrade. The Luftwaffe calculated raid timing, escort positioning, and attack profiles based on pre-war assumptions about British fighter performance. The Rotol Propeller made those assumptions wrong. The RAF didn't just fight harder, they fought smarter and flew better performing machines. By the end of 1940, nearly every frontline Spitfire had been converted. The wooden two-pitch propeller, once considered cutting edge, had become obsolete in the span of a few months. And with that transition, the early Spitfire evolved from a promising interceptor into one of the most formidable fighters of the age. The story of the Spitfire is usually told with images of soaring wings, elliptical beauty, and brave young men defending their homeland. But beneath that romance lies the mechanical heart of innovation. The Spitfire was not a perfect machine at birth. It had flaws, it had weaknesses, and one of its greatest leaps forward came not from an ace pilot or a dramatic dogfight, but from a team of engineers who understood that performance comes from precision. And so when you watch footage of a Spitfire climbing steeply into a summer sky, or when you hear that unmistakable Merlin roar, remember this. Part of that grace, that power, that mythic reputation comes from a propeller invented by men whose names most history books never mention. Because sometimes the greatest heroes of war are the ones who never fire a shot. And sometimes the innovations that change history are not loud, dramatic breakthroughs, but quiet, elegant solutions that simply work better than anything before them. And the Rotol constant-speed propeller was exactly that. It made the Spitfire climb like no British fighter had ever climbed before. It gave pilots the power and altitude they needed when Britain's survival was on the line. And it helped ensure that when the Luftwaffe came across the Channel in the summer of 1940, the defenders waiting for them were flying fighters that, quite literally, reached the fight in time. A small change, hidden in plain sight, a forgotten engineer, a propeller that changed the war. And that is how a simple piece of British engineering brilliance made early Spitfires climb 25% faster, almost overnight.